Here we are going to find some inverse functions. In order to have an inverse function, you must have a function that is 1-to-1, which means each x only goes to one y and each y only goes to one x. So, for instance, if the graph looks like a parabola, that's a function because it passes the vertical line test. You can draw a vertical line anywhere and it will only touch the graph once. But it is not 1-to-1 because if we draw a horizontal line, it touches more than one time. So a function, a vertical line only touches once. A 1-to-1 function, a horizontal line only touches once. So that one is not 1-to-1, but like a linear function would be. You can draw any vertical line, it will only touch once. And any horizontal line, it will also only touch once. So that function is 1-to-1, or even an x cubed function will pass a horizontal line test and pass a vertical test. So we want to find some inverses, which will only happen for 1-to-1 functions. 1-to-1 means it passes the horizontal line test. So looking at these functions for g and h to start. So g of x is 3x plus 1, and h of x is x minus 1 over 3. So let's just plug in some functions and see what happens. So we have 3x plus 1, so 3 times negative 2 plus 1 is going to give me negative 5. Then if we plug in negative 1, we would get negative 3 plus 1 is negative 2. If you plug in 0, you get 1. Plugging in 1, you get 4. And plugging in 2, you get 7. On the other side, if we plug into x minus 1 over 3, notice if you're going to plug into a calculator for this, you need parentheses around the numerator. So parentheses x minus 1 and then over 3. So 7 minus 1 is 6, divided by 3 is 2. If you plug in 4, 4 minus 1 is 3, over 3 is 1. 1 minus 1 is 0 over 3, which is 0. And negative 2 minus 1 is negative 3 over 3, which is negative 1. And negative 5 minus 1 is negative 6 over 3, is going to give me negative 2. So looking at this function, what do we notice? So for g, the points are negative 2, comma, negative 5. And then we have negative 1, comma, negative 2. 0, comma, 1. 1, comma, 4. And 2, comma, 7. Whereas for h, we have the point 7, 2 to start. And then the next point is 4, 1. The point after is 1, 0. Moving up, we would have negative 2, negative 1. And lastly, negative 5, comma, negative 2. So what's happening with these? X is negative 2 gives y is negative 5, whereas on h, negative 5 gives negative 2. Here we have negative 1, comma, negative 2, switches to be negative 2, comma, negative 1. 0, 1 in g is 1, 0 in h. 1, 4 in g is 4, 1 in h. And 2, 7 in g is 7, 2 in h. So this is a property for inverses. X's and y's are switched, which means g of x, which is 3x plus 1, and h of x, which is x minus 1 divided by 3, are inverses. They're inverse functions if x's and y's are swapped between the two, which kind of makes sense if you think about the functions. This has x times 3 plus 1. What's the inverse or opposite of that? Well, we have plus 1 and the original minus 1 is the opposite. And the opposite of multiplying by 3 would be dividing by 3. So we have inverse operations, and we can tell because x and y are switched. There's the key to telling if something is an inverse. X's and y's are switched.